October 20th, 1944. The island of Leyte, Philippines. Dawn breaks in shades of smoke and salt water. The air carries the smell of diesel fuel, of churned red earth, of the ocean boiling behind 10,000 landing craft. From the steel ramps of those vessels, American soldiers wade ashore through the warm shallows, their rifles held high, their boots sinking briefly into the sand before finding purchase on solid ground. General Douglas MacArthur, yet who 2 years earlier had been forced to flee these very islands in darkness and disgrace, wades ashore with them, keeping a promise he had made to a people who still believed in the idea of liberation. But the soldiers who moved most quietly that morning, the ones who drew the least attention, were not the riflemen of the infantry. They were the engineers. They carried no flags. They gave no speeches. They waded ashore with shovels, with pneumatic floats wrapped in canvas, it with prefabricated steel panels stacked on landing craft, with coils of cable and crates of anchor chain. They carried, in short, the tools of a civilization that had learned to build faster than any enemy could destroy. And in the weeks that followed, across the flooded rice paddies and swollen rivers of Leyte, across the burning streets of Manila, and across every contested waterway between the beachhead and the interior, those engineers would do something that the officers of the Imperial Japanese Army were not prepared, by training or by culture or by ideology, to believe was humanly possible. They would build bridges, not in days, not after careful surveys and prolonged deliberation. They would build bridges capable of carrying 33-ton Sherman tanks across rivers still under enemy fire in a matter of hours. And when Japanese officers, both those who watched from the far bank and those who were eventually captured and brought to witness the American machine in full motion, confronted that fact, something shifted inside them. Not merely tactically, not merely strategically, but at the level of the world as they understood it. Something in the architecture of their belief cracked, slowly and irreversibly, like the first fracture in a dam that holds back more water than it was ever built to bear. To understand why that moment shattered something so deep, one must first understand what they were looking at, and why no one in Japan had ever taught them to expect it. The Imperial Japanese Army was, in its essential self-understanding, a warrior institution. Its founding mythology reached back through centuries of samurai culture, through the austere code of Bushido, yes, through a tradition that placed spiritual intensity above material preparation and personal sacrifice, above logistical calculation. When the Meiji Restoration of the late 19th century had modernized Japan with startling speed, folding Western technology into a fundamentally feudal military culture, the officers who emerged from that process carried both worlds inside them. They had modern rifles and ancient contempt for anything that smelled of the warehouse, the factory floor, or the supply depot. They understood horror as the clash of will and spirit. They understood victory as a function of moral force. And they understood the men who built bridges and repaired roads and calculated tons per axle as something considerably less than warriors. That cultural disdain had consequences that stretched back further than most histories acknowledge. At the time of the Russo-Japanese War of 1905, barely 4% of Japanese military academy graduates chose to enter the logistics corps, not 4 out of 10, 4 out of 100. Transport officers were explicitly ineligible for admission to the Japanese War College, the institution that trained the Imperial Army's future leaders. The message delivered by that single administrative rule was clear, and it was delivered to every ambitious young officer who read it. Logistics is not warfare. Engineering is not warfare. And the men who move supplies and build bridges are not the men who matter. The Pacific War Online Encyclopedia, drawing on decades of documented military records, would later assess that as many as 60% of all Japanese military deaths during the Second World War were attributable not to enemy fire, but to starvation. a catastrophic legacy of the philosophy that had been quietly encoded into the Imperial Army's soul long before the first bomb fell on Pearl Harbor. Japanese engineer units in the Pacific were, by any material measure, inadequate for the scale of the war they were fighting. A standard Japanese division included an engineer regiment of roughly 900 to 1,000 men, but those men were furnished almost no heavy construction machinery. Bulldozers, that fundamental instrument of American engineering power, were nearly completely absent from Japanese engineer inventories. What the Japanese Army offered its engineers in place of machinery was, in its own grim way, a kind of courage. In improvised river crossings during the early campaigns, Japanese engineers sometimes stood chest-deep in stream beds, holding wooden planks on their shoulders so that assault infantry could cross on their backs. It was an image of extraordinary human endurance, and it was also an image of a military institution that had decided human bodies were cheaper than building equipment, and that had organized its entire engineering philosophy around that calculation. The construction units the Imperial Japanese Navy had organized, beginning in November 1941, designated Setsueitai and composed largely of Korean and Taiwanese laborers led by Japanese officers, never achieved more than a fraction of the capability of their American counterparts. Well, not because the men who built them lacked intelligence or determination, but because the resources allocated to them, the machinery assigned to them, the industrial infrastructure behind them, reflected a nation that had chosen to invest its pride in the sword rather than in the steel plate and the pneumatic float. Across the Pacific, in the factories of Pennsylvania and Ohio, in the manufacturing towns of Michigan and Indiana, a different philosophy had been taking physical shape. It had been taking shape for years before the war, encoded in the culture of a nation that had built its identity not on the sword, but on the wrench and the blueprint. When the United States entered the war in December 1941, American industry did not merely begin producing weapons. It began producing civilization at industrial scale, the roads, bridges, airfields, and port facilities without which no army, however brave, could move, be fed, or sustain itself in the field. By the time the war ended, American factories had produced 300,000 military aircraft, 110,000 tanks, more than 2 million trucks, over 6,000 ships, 80,000 landing craft, and 2.5 million machine guns. These were not the statistics of a nation at war. They were the statistics of a nation that had reorganized the entire physical output of its civilization toward a single strategic purpose, and that had done so with a speed that no one on Earth had predicted was possible. The engineers who carried that civilization ashore at Leyte were the product of that same system. At its peak strength during World War II, the United States Army fielded over 700 engineer battalions, a figure that represents not just a quantity of men, but an entire industrial ecosystem of doctrine, equipment, training, and supply that had been built from nearly nothing between 1940 and 1944. These were men who had learned their trade not in feudal academies where logistics was a mark of weakness, but in a civilian society where the ability to build something fast, and then build it strong enough to carry the weight demanded of it, was the measure of a craftsman's worth. Many of them had been construction workers before the war, iron workers, carpenters, road builders, bridge builders. They carried their civilian competence with them into uniform, and the Army had given that competence a machine. That machine was the M2 steel treadway bridge. It was not a beautiful object. It was not meant to be. It was a modular system of prefabricated steel panels, each section constructed to interlock with the next, supported by pneumatic rubber floats that were inflated and deployed into the water, while the steel decking was slid forward across them. The system had been engineered to carry a 40-ton load, which meant it could carry the 33-ton M4 Sherman medium tank, the primary American armored vehicle in the Pacific, with margin to spare. The M2 system had been developed specifically in response to the introduction of the Sherman. Our earlier pontoon bridge designs had been rated for only 25 tons, and the adoption of the Sherman in 1942 had forced a redesign of the entire bridging system. That redesign, methodical, unglamorous, carried out by engineers in training depots and testing ranges rather than by officers in war colleges, represented precisely the kind of institutional adaptability that the Imperial Japanese Army had never built into itself. The field performance of the M2 system, when American engineers put it into use, was something that even the engineers themselves sometimes found difficult to believe. In September 1944, American engineers built a pontoon treadway bridge over the River Seine at Rosny-sur-Seine using more than 1,150 feet of M2 treadway and 93 pneumatic floats. The total construction time, from the moment the first float entered the water to the moment the first vehicle crossed, was 6 hours and 15 minutes. 1,150 feet, 93 floats, 6 hours, in the field, under operational conditions. 1 year later, on the night of March 24, 1945, the 17th Armored Engineer Battalion, attached to the 2nd Armored Division, pushing into the heart of Germany, built the longest treadway pontoon bridge that had ever been constructed anywhere in the world. It stretched 1,146 feet across the Rhine River at Wesel, Germany. It carried Sherman tanks, artillery pieces, trucks, half-tracks, and the entire weight of an armored division pressing into the German interior. It broke every existing bridge construction record, and it was built in 9 hours. 9 hours to span the Rhine, a river whose crossing had defeated armies and reshaped civilizations, with a structure capable of carrying armored vehicles in combat. In the Philippines, on the other side of the globe, the story repeated itself with variations that felt almost routine to the Americans who lived it, and nearly incomprehensible to the Japanese officers who witnessed it. When MacArthur's forces landed at Lingayen Gulf in January 1945 and began their drive south toward Manila, combat engineers moved with the advancing columns, repairing or replacing every bridge the retreating Japanese forces had destroyed. And the drive covered 110 miles, from the beaches of Lingayen to the gates of Manila, through terrain that offered rivers, ravines, and washed-out roads at nearly every mile. Engineers of the 6th Army built bridges under sniper fire, under artillery fire, in the dark, in the rain. At the 127th Combat Engineer Battalion built a pontoon bridge across the Pasig River in Manila in February 1945 as refugees were still crossing it. The bridge completed in record time while the battle for the city raged on both banks. The 530th Engineer Company's Corporal Francis Callahan later recalled the urgency of those days, the sense that the bridge was not merely a structure but a lifeline through which the liberation of a city and its people was flowing. Yet the Leyte campaign alone had required 21,097 engineer soldiers, including 15 aviation engineer battalions and 3 construction battalions. That number, more than 21,000 engineers for a single island, speaks to a truth about the American way of war that the Japanese military had never fully absorbed from its study of American character. The United States did not merely fight with soldiers, it fought with infrastructure. It understood, yet at an institutional level that went all the way down to the basic table of organization of an infantry division, that an army that cannot move cannot win, and that the ability to move across broken terrain, across destroyed bridges, across flooded rivers, was not a logistical nicety, but a strategic weapon as decisive as the Sherman tank that crossed on the bridge the engineers had just built. In the Imperial Japanese Army's worldview, the engineer was an afterthought, a necessary but undistinguished figure who followed behind the warriors and repaired what the warriors had used. In the United States Army's worldview, the engineer was a force multiplier, a specialist whose work translated directly into the speed of advance, the weight of firepower, and the momentum of the offensive. The difference between those two understandings was not merely administrative, it was philosophical. And it was the difference between a military that had organized itself around the idea of the individual warrior's spirit and a military that had organized itself around the idea of the industrial system's output. And in the end, across the rivers and rice paddies of the Pacific, that philosophical difference expressed itself in a very concrete measurement. The weight of a 33-ton tank crossing a bridge that had been built in less time than it took to hold a regimental planning meeting. Yeah, there were Japanese officers who watched this happen. Some watched from the far bank before they were driven back by the advance. Some watched later, under very different circumstances, after capture had stripped them of everything except their power to observe and to think. What those observations produced in them was not immediately despair. The first emotion was closer to disbelief. Not the disbelief of a man confronted with a magic trick, yes, but the deeper disbelief of a man confronted with something that his entire education has told him cannot exist, and which exists anyway, regardless of what his education told him. They had been trained in a military culture that treated engineering as a secondary art, that assigned to it the dregs of ambition and the minimum of resources. And they were now watching men, American enlisted men, not officers, not elite special forces, unload prefabricated bridge panels from trucks, how to float them on pneumatic pontoons, slide them forward over the water with the casual efficiency of a practiced trade, and have a structure capable of carrying armored vehicles ready in the span of a single working shift. One does not need a specific captured document or a single officer's testimony to understand what those men felt in that moment, because the reaction was documented broadly across the Pacific War in the responses of Japanese officers and men to American industrial capability at every scale. When Japanese prisoners of war were eventually brought to the United States, to camps in Nebraska, in California, in the deep interior of the American continent, they were shown things that altered their understanding of what the war had actually been about. In Nebraska, groups of Japanese prisoners were taken to observe the mechanized harvest of American wheat fields. They watched combine harvesters, machines of a scale and a capability that had no equivalent in Japan, move through fields that stretched to every horizon, gathering in a single hour what would have taken a Japanese farming village days to collect by hand. One Japanese officer, according to records that have survived in American camp documentation, is reportedly stated that if Japanese leaders had visited American farms, seen American factories, and understood the actual scale of American production capacity before December 1941, the attack on Pearl Harbor would never have been authorized. He was not wrong, but his insight came too late, delivered in a Nebraska wheat field with the war already decided, as the sound of a combine harvester replaced the sound of carrier planes over Pearl Harbor in his mind. Yet the men who had chosen war had chosen it on the basis of a belief that spirit could overcome material, that courage could outlast supply, that the way of the warrior was more decisive than the way of the engineer. It was a belief as old as Japan's military mythology and as recent as the morning briefings that had preceded every major Japanese offensive in the Pacific. And it was wrong. The steel treadway plate itself, that individual, modular, yes, interchangeable unit of the M2 bridging system, deserves a moment of consideration as an object, because in its physical reality, it contained the entire argument. Each steel treadway section was manufactured to precise tolerances in American industrial facilities, far from any battlefield. It was designed to be handled by ordinary soldiers without specialized equipment, to interlock with the sections beside it without the need for custom fitting, and to perform its function identically, whether it was placed on the Rhine in Germany, the Seine in France, the Pasig in the Philippines, or the Leyte interior in the tropical Pacific. It was a component of a system that had been designed from the beginning with standardization as its highest engineering virtue, because standardization was what allowed volume, and volume was what allowed the United States to build 700 engineer battalions and equip every one of them with enough bridging material to span a river under fire. The steel plate did not care about Bushido. It did not distinguish between the warrior and the supply clerk. It crossed rivers equally for every man who walked on it, carried every tank that drove over it, and bore the full weight of the American military system with the same indifferent structural integrity every single time. It was, in a sense, the most democratic object in the entire Pacific theater, a piece of industrial infrastructure available to every soldier equally, the product not of individual courage but of collective industrial will, not of a warrior elite but of a manufacturing civilization that had decided every soldier deserved a bridge that could hold. The American ration allowance tells a parallel story in a different material. An American infantryman in the Pacific Theater was allocated 4,758 calories per day. A Japanese soldier in the same theater was sometimes allotted as little as 600 grams of food, approximately 1,300 calories of uncooked rice and soybean paste per day, to be supplemented by whatever could be foraged from the surrounding terrain. At the time Japan attacked Pearl Harbor, the average Japanese civilian was already living on 2,000 calories per day. By 1945, that figure had dropped to 1,680. Japanese commanders on Pacific Islands in the later campaigns were not fighting with armies. They were fighting with men in the advanced stages of starvation, men whose bodies had consumed their own muscle tissue, whose minds had narrowed to the single point of hunger, and whose military effectiveness had been destroyed not by American firepower, but by a logistics system that had never been built to sustain them. The Pacific War online encyclopedia's estimate that 60% of all Japanese military deaths were caused by starvation is not a statistical curiosity. Yet it is the final arithmetic of a philosophy, the philosophy that glorified the warrior and neglected the supply officer, working itself out to its conclusion in the bodies of the men who had been asked to fight without being asked whether they had been fed. Across that starvation and across that philosophical void, the sound of the American engineer at work was something that Japanese forces encountered again and again as the island-hopping campaign gathered momentum through 1943 and 1944. At the Seabees, the United States Navy's Naval Construction Battalions, formed in March 1942 from a corps of civilian construction workers who brought their entire professional skill set with them into uniform, became a particular source of bewilderment and dread for Japanese commanders. When Seabees landed on Vangunu Island in the New Georgia campaign in the summer of 1943, they built a fully operational airfield in 72 hours. Japanese engineering assessments of the terrain and resources available had placed the construction of such a facility at 2 to 3 weeks of intensive effort under ideal conditions. After the airfield was operational and American fighters were using it to achieve air superiority over the next stretch of ocean, Japanese engineers who were later debriefed on the subject reportedly described the achievement as simply impossible, a word that, in this context, it meant not that the thing had not happened, but that the category of experience available to them had no place to put it. At Tarawa in November 1943, Seabees had the captured airfield back in operational condition within 15 hours of the Marines securing the island, while the dead were still being counted on the beaches. The pattern repeated itself across Bougainville, across the Admiralties, and across the entirety of General MacArthur's Southwest Pacific campaign. American engineers arrived on captured territory and immediately began building. Roads appeared from jungle. Airfields rose from coral, port facilities materialized from empty beaches, and bridges, always bridges, replaced every blown crossing, carrying the weight of tanks and artillery and the endless, inexhaustible flow of American supply forward toward the next objective. But the transformation this produced in Japanese military thinking was not a clean conversion. It was more like a slow geological pressure, the kind that does not announce itself as it builds, but that eventually reshapes the entire landscape. In the early months of the war, Japanese commanders had dismissed American industrial capacity as a factor that courage could overcome, the same dismissal that had animated the decision to attack Pearl Harbor itself. By 1943, that dismissal had become more difficult to maintain. By 1944, it had effectively collapsed, not in a single moment of revelation, but in the accumulated weight of 1,000 observations. An airfield where there had been jungle 2 days ago, a bridge where there had been a destroyed crossing this morning, a column of Sherman tanks rolling across a river that had been a barrier an hour before. One of the most striking of those observations was recorded indirectly through the post-war testimony of Japanese officers who had served in the Philippines during 1944 and 1945. They described the experience of watching American engineer units at work as something that disturbed them at a level that tactical analysis could not fully account for. They understood that the Americans had more equipment. They understood that the Americans had more supplies. Yet what they could not fully integrate into their understanding was the speed. The fact that American engineers did not seem to regard the construction of a tank-carrying bridge as an exceptional achievement requiring exceptional men. They regarded it as their job. They arrived at a riverbank, assessed the situation with the practiced eye of men who had trained for exactly this circumstance, deployed their equipment with the coordinated efficiency of a team that had rehearsed every step, and produced a functional structure in the time it would have taken a Japanese engineer battalion to complete a preliminary survey. The Americans were not performing miracles. They were doing their jobs. And that, in a profound way, was the most disturbing fact of all, because it meant that the American capacity to build bridges in hours was not the product of special circumstances or exceptional effort. It was the product of a system that manufactured the equipment, trained the men, organized the doctrine, supplied the material, and positioned the units such that the construction of a 40-ton bridge over a combat river was simply what those units did, routinely, professionally, as a matter of established practice. It was, in the most literal sense, the industrialization of military engineering. And it reflected an American understanding of warfare as fundamentally an economic and industrial activity governed by production rates and supply chains and logistical calculus, rather than a spiritual and martial activity governed by willpower and sacrifice. General Walter Kruger, commanding the 6th Army during the Luzon campaign, was characteristically blunt in his assessment of what engineer bridging had meant for his offensive. When his forces were racing the 110 miles from Lingayen Gulf toward Manila in January 1945, every river crossing had been prepared for demolition by the retreating Japanese. Had those crossings remained demolished, and the advance would have stalled, the momentum would have broken, and the Japanese defensive positions around Manila would have gained weeks of additional preparation time. But the engineers were there. At each destroyed crossing, combat engineer companies deployed their treadway bridge equipment, inflated their pontoons, laid their steel decking, and had the crossing open for armored vehicles within hours. The momentum of the advance was not interrupted. Manila fell in February 1945, on a timetable that the defending Japanese forces had calculated was impossible given the terrain and the destroyed road network. They had calculated correctly by their own standards, but their standards did not include the M2 steel treadway bridge or the men who had been trained to build it in the dark, under fire, in 6 hours flat. At Corporal Francis Callahan of the 532nd Engineer Company, later described the construction of the Pasig River Bridge in Manila during the battle for the city. His unit had completed the crossing in record time, even as Japanese snipers fired from the south bank and artillery rounds fell within range of the construction site. The engineers worked day and night, the official record states, oftentimes under intense sniper fire. The phrase reads almost casually in the historical record, as engineers working through the night under sniper fire to build a bridge that tanks could cross. It is worth pausing on the image for a moment. The flicker of muzzle flash on the dark water, the clang of steel treadway sections being slid into position, the hiss of pneumatic floats being inflated, and the shouted coordinates and the measured professionalism of men doing their jobs in the middle of a battle, because that image captures something essential about what the American engineer represented in the Pacific War. He was not a soldier who built things when the fighting stopped. He was a builder who fought while he built, yes, and who understood that the bridge he was constructing was itself a weapon, perhaps the most decisive weapon on that particular stretch of river on that particular night. The 233rd Engineer Combat Battalion, operating in the European theater but representative of the Pacific deployed units in doctrine and capability, built 26 bridges during its campaign, some of them under enemy fire, many of them interrupted by enemy patrol action, none of them left unfinished. And their history notes matter-of-factly that they built those bridges regardless of the conditions, repaired what had been damaged, and moved forward to the next river crossing. 26 bridges. That number, multiplied across 700 engineer battalions across every theater of the war, Bambu gives some sense of the total structural transformation that American engineering imposed on the physical geography of the Second World War. A transformation so comprehensive that it effectively altered the terrain itself, making rivers into roads, turning defensive barriers into avenues of advance, converting every waterway that Japan and Germany had counted on as an obstacle into a crossing point on the American timetable. The symbolic weight of that transformation cannot be fully separated from what it meant politically and ideologically. The bridge, as an object, as an idea, is one of the most eloquent physical metaphors in human civilization. It joins what was separated. It makes passage possible where passage was prevented. It insists, structurally and materially, that separation is not permanent, that barriers are not final, that the territory on the other side of the water is reachable. It's when American engineers built tank-carrying bridges across rivers in hours, they were not merely solving a tactical problem. They were making a statement about the nature of their civilization. A civilization that had organized its industrial and technical capacity around the principle that obstacles could be overcome, that problems could be solved, that the river was not a boundary, but a challenge, and that the challenge was answerable. The Japanese officers who watched from the far bank, or who were later confronted with the evidence of what American engineering had built, were confronting something more profound than a military capability. They were confronting a different philosophy of what human beings could accomplish when a free, industrial society decided to apply itself fully to a problem. They had been told, by their education, by their culture, by their military's highest philosophy, that the decisive variable in war was the warrior's spirit. They were watching a 33-ton Sherman tank roll across a bridge that had been built in 6 hours by men in work uniforms carrying steel plates, and the tank was moving without ceremony, without drama, across a river that had been an obstacle this morning. The spirit of the warrior had met the steel of the engineer, and the steel held. In the years after the war, as Japan rebuilt itself and came to terms with the catastrophic cost of the philosophy that had led it to Pearl Harbor and beyond, the memory of what American engineering had represented in the Pacific would take on a different kind of weight. Japanese officers who had survived the war and entered the Reconstruction period brought with them the accumulated evidence of 100 specific moments. An airfield built in 72 hours, a pontoon bridge built in 6, a 1,000-foot span across the Rhine in 18 hours, a supply chain so abundant that American soldiers were allocated almost 5,000 calories a day, while Japanese soldiers starved. The lesson encoded in those specific moments was not about American superiority in some abstract or permanent sense. It was about what happens when a nation invests its highest institutional energy in the unglamorous, undramatic, but ultimately decisive work of building things, and building them well, and in building them fast, and building them in sufficient quantity that the enemy runs out of rivers before you run out of bridge. There is a particular quality to the sound of steel treadway panels being laid across pneumatic pontoons in the dark hours before dawn. It is not a beautiful sound. It is metallic and purposeful. The clang of flat panels connecting, the splash of floats settling into current, the shout of men calling measurements across fast-moving water, Yes, it is the sound of an army that understands what it needs to do and has been given the tools to do it. It carries within it no romance and no poetry. It is entirely, uncompromisingly practical. But in its practicality, it carries something that the warrior's code, for all its elegance and its centuries of refining, could not carry. The sound of a civilization that has decided, collectively and irrevocably, that no river is wide enough, no barrier permanent enough, and no obstacle final enough to stop the advance of free men who have been given good steel and the training to use it. The bridges held, the tanks crossed, the cities were liberated. The men who built those bridges came home to the towns and counties they had left, returned to the construction companies and the iron-working shops and the road-grading firms where they had learned their trade, and went back to building things, highways, dams, overpasses, and the physical infrastructure of a post-war prosperity that was itself, in a way, the same argument they had been making in the field, that a society which builds well, builds fast, and builds enough is a society that endures. The rivers of Leyte and Luzon still run south to the sea. The waters that bore those pneumatic floats in the autumn of 1944 have long since reached the Pacific and dispersed. But somewhere in the historical record, in the after-action reports of engineer battalions, just in the quiet pages of bridge construction logs that list river widths and construction times and vehicle loads with the bureaucratic precision of men who understood that the numbers mattered, somewhere in all of that, the full account of what was built exists. Thousands of bridges, built in hours, carrying tanks across the rivers of a war. And on the far bank, every time, was the future, a future that the Japanese officers standing at the waterline, he watching the steel decking slide out across the water toward them, had not been equipped to imagine, but which was coming toward them nonetheless, carried on pneumatic floats and steel treadway, crossing the river in the dark, panel by panel, unstoppable as the current below it, and as certain as the dawn.